Hi, this is Bill Berry with a gentle introduction to functions. If you're new to functions, the concept might be a little bit foreign, and to make sure that you've got a sort of an easy way to get started, let's start with a non-technical concept, and then we'll develop it into something closer to code. And then once you read the chapter or see other videos that talk about the code to implement them, they will make more sense to you. So let's get started with that. First of all, let's start with the concept called the lazy professor. The lazy professor is one who has decided to outsource some pre-lecture work. He's tired of doing all these things himself. It maybe feels too complicated as he's getting started with his lectures. He'd really like to focus on the lecture material, so he's trying to kind of get rid of that stuff and simplify his life by having some helpers do some work for him. He does have some eager students, so we have Susie, Francisco, and Yuka, who are all going to be helpful in this process. So they're going to help the professor. The first thing we have to do is figure out what tasks he needs help with. So we've made a little table here that says which student's going to do what tasks. So Susie's going to sign up for the get snacks task. And if a specific description here is given, there's this vending machine on the second floor and he likes a bag of Fritos, so you have to get a bag of Fritos. Then you have to go to the third floor and there's another vending machine there to get a Pepsi, and then from the bookstore you go and get a tin of mints. So there's some tasks that need to be done, and Susie's going to be in charge of that getting the snacks business, so it's all set. Francisco is going to work on the get markers task, and so he has to go to the professor's office and grab a box of colored markers and an eraser so that that's in place before the lecture starts. Yuka is going to take care of the write on the board task, and that is that on the whiteboard she's going to write today's date and the name of the lesson that's going to be covered today. So each student has a really specific task, and the description is sort of defined, right? We know what task is going to happen and what that task is supposed to do. Well, that's great, but we're really not quite ready to get started. The professor can't just tap Susie or call out get snacks and have her do the work, because we really haven't quite fleshed out an important piece of this that we'll call the contract. We have the description of the task, but we really don't have the full contract described. There's another piece that we need to talk about. Specifically, when the student starts the task, they may need something to be given to them. They need something to come in their world, right? Come into their world in order to start the work. Then they do the work, and there may be some stuff that they need to give back. Why? Because the professor needs it to move forward with other parts of the thing, right? So stuff can come in and stuff can go out. For instance, Susie, the get snacks person, needs some money, right? It's not her money she's going to spend, it's the professor's money. So she needs some money to be started, to start the task. She needs to be handed some money. When she's done, what does she need to give back? Well, the snacks. Her whole point of her task was getting the snacks, so she better give those snacks back at the end or the professor will be hungry. And then there might be some change, and if there's change, of course, she needs to give that back as well. So this is the contract for her task, and similarly Francisco, the get markers guy, he doesn't necessarily need anything to get started. He's, he can sort of do the thing on his own, but then when he's done, he has to produce the things that he was tasked to get, which is the markers and the eraser. How about Yuka? Well, she's going to write on the board. Well, she needs the lesson title. She probably doesn't know exactly what the professor wants to call this lecture. She knows today's date, so she doesn't need that, but she needs the lesson title. But interestingly, when she's done, she doesn't provide anything back. Right? That's not a problem. So it's okay for sometimes for us to have things that tasks that need stuff to come in and go out. Some of them only need ins, some of them only need outs, and some of them don't need any of the above. So we'll continue to talk about that, but this is a great way to look at the contracts. So if you see the student having this list of contract stuff coming in, stuff coming out, and a description of what they're supposed to do, can go out and do that. So that's fantastic. We've got a great start to this whole contract business, and now the professor can actually say, get my snacks. And Susie, when he hands her the money, of course, as part of that, can go and do the tasks, bring back the stuff, hand it over, and the other tasks can also be done. So this is the general idea of getting help, and this is parallel to the concept of functions. We'll continue to develop that here. Let's talk about some important notes. In fact, let's go back a little bit. Notice one of the things, the professor is getting help with this. It doesn't necessarily mean the tasks go faster. Generally, programs work very sequentially, and typically without a lot of other work, they work on a single thread on a single processor. So that means these tasks are not going to actually be completed any faster than if the professor had done it himself, more or less. But it is a simpler life for him, and he can maybe, conceptually it's a simpler start for his lecture. So let's go and talk about some of the other important notes. First of all, think about the ins and outs from the perspective of the student doing the task. So don't get confused with ins and outs because you thinking about both the professor and the student at the same time. Don't do that. Put yourself in Susie's shoes. Get my snacks. What comes in is the money. What goes out is the snacks and the change. So when you think about these coming in and going out, always think of it from the perspective of the task, the individual task, so you don't get confused. Second, we talked about the fact that some of these tasks have nothing that's handed back. Don't confuse stuff being handed over as with real work being done, because people can do real work, right? So don't confuse those things. It's okay if there's nothing handed back, and that's not a problem. Also, each student fulfills their contract, but it really doesn't specify how they do their work. For instance, Susie could decide to take the elevator, but she might take the stairs. She might sing a song or whistle as she goes. Doesn't matter any to the professor, right? She might choose to get the mints before the Pepsi or vice versa. Really, the professor doesn't care, and it's not important to this process. She is independent. Her task is completely independent as long as she takes care of the contract, fulfills the contract, and she does what was described as her job. So that's kind of cool. It's really nobody's business how the task works. It's Susie's job, and that's why we like things to be very independent, right? We like this in life, we like this in functions. Next point, the student might decide to further contract out the work. For instance, Susie could say, wow, this is a lot of work running up and down the stairs, going to all these floors, get different vending machines. Like, I need some help with this. So she might actually hire some other students to do work, and she might have some sub pieces of Get Snacks called Get the Fritos. And that might be Dana, and Lupe might get the Pepsi, and Chris might get the mints. Now, to the professor's perspective, it doesn't matter. He taps Susie to get the snacks, and when it's all done, Susie gives the snacks back, but she has contracted out the work kind of under the hood, right? You don't see that. The professor doesn't know. He doesn't care. It doesn't actually matter. He's unaware of it, but it still gets fulfilled. The contract is still fulfilled exactly as he talked about. It's just that she asked for some helpers under her. Perfectly legal, perfectly fine, and we like that, in fact. If her task is complicated, in fact, she should do this. Last part, we talked about this. Some contracts have ins and outs, some only have ins, some only have outs, and some have neither. So it doesn't really matter. Don't worry about the fact that some data flows back and forth, and some functions can happen and do things very quietly without a lot of conversation. That's perfectly fine, not a problem. Now let's take a step toward code at least, and let's see how this starts to move into the actual coding world. First of all, let's talk about a call hierarchy. This is a useful way to visualize who is responsible to whom for doing the tasks. So in this case, we have the professor at the top. That's going to be our main program, as we're going to see in a minute. And then we have the professor needing three things. So he calls for three things to happen. Get my snacks, get my markers right on the board. Now, we've also seen that Susie can contract out, so Get Snacks might call these other things, Get Pepsi, Get Fritos, and Get Mints. But this is the call hierarchy that we're going to see here, and this is a good way to visually see what's happening in the program, which function calls which other function. Now, some folks might like to annotate this with a little note saying, hey, I need to, I'm gonna write what data goes. So I could make a little arrow here that says, when Get Snacks gets started, we need money to come in, and when this is done, we need change in snacks to go back. So you could draw some little arrows and actually show it on these functions, but we'll sort of leave it simple for now. Now, the other thing that's implied here, if you look carefully at this call hierarchy, there is an order of things. And again, typically programs run on one thread, one processor, and so actually this is exactly the order in which all of this is going to happen, with some of the tasks sort of on hold as the other tasks run. So here's how it works. Professor says, get my snacks. Get my snacks calls get the Pepsi. The Pepsi does its work, and then when it's finished, it passes back the Pepsi and passes back program control, back to Get Snacks. Get Snacks calls Get Fritos. Get Fritos does its work, passes back the Fritos. There's some change that has to go. We didn't write that, but that's okay. And then Get Snacks calls Get Mints. Get Mints does its work, passes back the mints and some change, and it also passes then program control gets back. Now, interestingly, while Get Pepsi is running, Get Snacks is paused. In fact, main, the professor, is paused, right? This is not a parallel to the real world, but that's how it works in the computer. Professor is paused, Get Snacks is paused, Get Pepsi is the only thing that's actually doing work at this moment. Interesting. So think about that, and you can walk through this and see that each thing, when Get Snacks is completely finished, it passes these information, but it passes the snacks and the change back to the professor, and then professor can call Get Markers. It does its work, passes control back to professor along with the markers. And the eraser, professor calls Write on Whiteboard, it finishes work, and then it passes nothing back, just passes program control back to professor. So it's interesting to think about it, what is paused, but really only one thing is running at a time typically, unless you learn some pretty, interesting and advanced concepts. So that's the general way of how things work and the order, the exact order in which things get called. Now, one of the interesting things is, let's say that we interrupt a task midway through. For instance, let's talk about Get Mints for a minute. Right? Let's say that the student is on the stairs from the third floor on the way to the first floor to the bookstore, and the dean, or let's say campus security, happens to run into this guy, and this is actually whoever, I don't remember who's doing this one. Anyway, runs into this person and says, "Hey, where'd you come from? How did you get here?" And Get Mint says, "Hey, I was tapped by Get Snacks. All I know is the Get Snacks guy asked me to do this work." And since we also know, again, these other things are paused, we are waiting for some things to complete. So we actually know Get Snacks was called by the professor. So this is called a call stack. If we interrupt a program, a function running, we can see, let's say at a certain line, that we are in Get Mints, which was called by Get Snacks, which was called by the professor. Notice we often see this in reverse order because we see it from the perspective of that task, who called me. So often you'll see it listed sort of backwards from what you might expect to see, but that's how you read it, right? Is everything knows who called it and what is paused and waiting for some work to complete. Hopefully that helps you understand the order in which things are called and this idea of a call stack. How did you get here, and what is everything that's paused waiting for you, waiting for some work to complete? Let's also take a step forward toward functions. We're not in code yet, we're sort of in pseudocode land, but each one of these ins and outs, right, are going to become part of a function definition. Right? So we're going to define a function called Get Snacks. We know what comes in, that's the money, and we know what comes out, that's the snacks and the change. And then it has a bunch of tasks, and then we define Get Markers. So slowly we're sort of moving these contractual pieces. The agreement of what comes in and out becomes part of the contract definition, the contract for a function. So that's a helpful little piece to consider that. Now let's actually move it into code and see in Python what that might look like. So each one of those in things becomes a parameter, and each out thing becomes a return value. So we know that we're going to define a function called Get Snacks. It needs some money, and we put a colon. And then we space in, because everything in Python, of course, is controlled. The start and end of things are controlled by tabbing or spacing in. And we then put whatever tasks need to be done, of course, and then we return the snacks and the change. So this is the ins and this is the outs from each function. Get Markers has nothing coming in, but at the end returns the markers and the eraser. Write on Whiteboard, you need the lesson title to come in, but there's no returns at the end. Now we can actually define the main function. Main needs to have some snack money, so let's say we set a variable with snack money, we put in $7, and we have a lesson title, and we put in some text, Intro to Chemistry. Then we can call Get Snacks. We have to pass it always, right? It needs money, so the contract says you got to give it some money, so we give it some money. So you pass it some snack money, and then you need to save its return values because you want the snacks and the change for later use perhaps. So we have variables snacks comma change equals, we call Get Snacks, and we take its return value. Same thing with markers and eraser. We need to take those things as, we need to save those things, do something with them, and we call get markers. Notice there's nothing in parentheses because get markers has no ins. Last but not least, we call write on board. We call it with the lesson title because that's a necessary in, but notice there's no out. So in this case, there's no point putting a variable and then an equal sign on the left side of write on board because it has nothing to return to us, so there's nothing we need to provide there. So I hope you can see, using this in this little exercise, us walking through the concept of what does it mean to define a function and what are the contracts that are necessary. What's the contract between the calling program and the callee that we need to observe? And then we sort of slowly morphed that and understood pieces of it and morphed it into code. Of course, there's a lot more to cover in terms of code, and other examples will hopefully help continue to solidify this in your head, but hopefully this is a useful little easy intro so you can get the general concept of what functions work and at least one real-world example of how that might work. Let me know if you have questions. Appreciate you watching, and we'll talk to you soon in forums or in email.